Hello and welcome to ST118 Statistics and Applications Session 1. This being the introductory session, I'd like to touch on a few points so that your mindset and mentality is aligned with mine. Right. So, what am I talking about? I would like to discuss, first of all, why. Why are you here? Right. So that's important because if you're not sure, right, why you are here, why you're doing this course, why you're doing statistics, it will be I guess dangerous waste of time because eventually you forget everything and it'll be quite a loss in the sense that it's a very useful skill nevertheless, right? So we'll talk more about that. And I'd like to also discuss the situation, something uh, more useful to you. And then after that, we'd like to talk about a little bit deeper down population versus sample and sampling. The idea of sampling. And we'd like to talk also about uh, descriptive versus inferential statistics. Okay, first of all, why stats? Okay, I see some of you trying to raise your hand and say you want to do stats because it's a required course, right? It's a core requirement before you can graduate. It's a mandatory study subject and so on and so forth. It's a required prerequisite to do your favorite subject. So why can't you just do your favorite subject, right? Why must you go through this course that I guess many of you find it bitter, find it challenging, find it scary even. Actually, it doesn't have to be. Well, let me ask. How many of you plan to be a mathematician, statistician after studying statistics? Raise your hand. Anybody? Okay, I'm going to assume no one. All right. Uh, and that is the correct response. Because if you do plan to become a mathematician, statistician, uh, you are probably not in the right course. You should do something that is more rigorous towards training you to become producer of statistics. All right. So a producer of statistics will be number crunching and generating statistics and analysis, right? And in a rigorous and high quality manner, and to be able to, handle various challenges. And those challenges can be uh, sensitive to the accuracy of statistical analysis. And as a mathematician, statistician, you will have to be equipped with enough theory to guide you, assist you, right, in being able to stand your ground and say that the results are credible and so on. But we are not. We are, however, consumers of statistics. You and I, okay, including mathematicians and statisticians. Like it or not, when you look at news, when you read news, if you read news, if you open up newspaper or you point at their website and have a look, or even if you watch YouTube on your favorite topics, whether it's cooking recipe, music making, dancing, whatever it is, the influencers, right? The ones producing those videos to teach you how to do things, they also tend to quote statistics. They might say, they might even cite other people's statistics researchers' analysis, right? To say that there's a research saying that most people tend to da 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 da, right? Those are the softer form of presenting to you numbers and statistics, but they are there if you pay attention. Reason you haven't identified those phrases as being statistics is because they are sugar coated in a way that is very easy to deliver to your ears and your brain, right? So in such a way that you will somehow have the buy-in. Why? Because when someone quotes or cites statistics, we tend to perceive them as being more powerful, more factually supported, and therefore more persuasive, isn't it? Yeah. So if someone were to say research shows that most people will buy life insurance, right, at the young age, and so after hearing that, you will tend to wonder how come I haven't bought yet, and you will start buying. But of course, you want to scrutinize a little bit more, right? What do you mean by research has shown? What research? Which research? What statistical proof has that research shown? If you don't know what questions to ask, if you don't know the procedures of statistical analysis, you wouldn't be asking the right question. You wouldn't be having the confidence, right, to challenge, to say which research, what analysis did they show, what results did they present, what is the sample size they did, right? In other words, how many people did they check with? One person or 1,000 people, right? The confidence level that research result gives to us will be very different. So that's the reason why you and I are here, to learn how to acquire this tool. What's this tool? This mental tool called statistics that would allow us to more able to digest the information and statistics that is presented to us. So we become a better consumer of statistics. When we become a better consumer of statistics, it's not that then we won't get indigestion, but yeah, in a way, then we'll be able to digest the information better, to be, number one, able to discern whether it's likely to be true or likely to be not true, right? Don't just look at statistics. It can also be poor in quality, right? Because it is based on a small sample size, for example. We'll talk more about that, right? And you also want to know, is this analysis credible, of high quality or not? High quality statistically or not? And having this mental skill allows us to be not just a better consumer of statistics, but also a better decision maker. After all, whether you're doing a university subject to be able to pass the tests, or you're doing your life decisions. Should I study for postgraduate degree or not? Should I buy a house in this location or not? At what price should I be asking? And so on and so forth, right? Many, many life decisions. And for that matter, when you get to work, you'll be meeting your boss, who will not listen to, I think, I feel this is a good idea, all right? But rather, what's your analysis? Well, of course, that comes automatically as a default expectation from bosses, right? They are not going to say, so what data have you got to support what you think? Come on, right? That's not going to be a explicit question to ask you to present statistics and data. You would have to do that automatically. So if you make a proposal, boss, I need to have a raise because I think I've been working very hard. Now that's not very convincing, and so bye bye, right? But if you can come up with data, results, performance analysis, right, and gathering the data and show that, hey, you know, you have accomplished 12 projects within a month, when, you know, as a matter of fact, most other colleagues accomplish only 4 or 5. Okay, you deserve a raise. Of course, that is already in company's record, but you're bringing this fact out in a powerful way to support your request for a raise in your salary, then that would add to your persuasiveness, that would add to your negotiation power, right? So all these are skills that you can groom yourself to become if you go with us through this course and through the statistics course that you have in your university or your program of study. Okay, so that's the reason why we want to be better decision maker, be better consumer of statistics, and better decision maker in general. And decision maker, I'm talking about any kind of decisions, big and small, whether in your career or in life. I'm sure you have a life, right? And you'll be making lifelong decisions, not just lifelong learning, but lifelong decisions. You're forever making decisions. Even deciding not to attend class is a decision, right? In preference to attend your friend's wedding or whatever it is, that is still a decision. Well, they have to be data based, based on facts, based on data, based on statistics, right? And so that is the reason why we are here. All right. So I hope you understand that if you do this, if you do statistics in a way that is diligent, that means usually what that means is you end up getting A or A plus, right? Because it will reflect in your ability to solve problems. So you do it in a way that is diligent. That will help you to sharpen your mind to be able to be a better, not just employee, but better parent even, to make decisions for your kids and your children, and basically a more likable person in general to be around with, right? So organizations will want you, headhunters will want you, and so on. So that's the whole point of studying statistics for most of us here. Okay, 99.9% of us. Right. Now some of you might say, hey, you know what? I'm also a producer of statistics because my company asked me to compile, right, the profitability of our quarterly performances for the past 3 years. So I produce the charts, I generate the average profits, the medians, the maximum, the minimum. I'm also a producer of statistics. That's true. That's true, right? But that is at the basic level of communication for statistics. When we talk about serious producers of statistics, we're talking about the statisticians who are working at the National Bureau of Statistics. In Singapore's case, it will be the SingStat, right? Singapore Statistics Bureau. And you need to be really rigorous and to cite and quote the relevant theorems to back up the claims and the procedures and steps that we perform in order to come up with accurate summary of data. Right? So that's the rigor that is involved to generate high quality end results. All these will be what a career producer, statistics producer will have to be dealing with. And I'm sure that's not you and I. Okay. My job here is to perhaps give you a guided tour, right? Hopefully in a light-hearted way. Now there will be parts where we cannot run away from the alphas and the betas, right? The summaries and the maybe even integrals, but by and large, they are just different form of communication symbols, right? But the way we do it here, we are seriously speaking not dealing with mathematics. Rather, we are just expressing an idea. For example, the idea of average. All right, we may write it as summation, right, of all the data divided by n, where n is the number of data. We may write it in mathematical symbol, but it's just conveying the idea of the average. And average, as I think everyone here understands, is a very commonly used and important statistic. Yeah, so that's the reason why we want to be able to be good with all these tools that statistical theory has already developed, and it is internationally understandable and internationally acceptable as a argumentative tool, right, to convince people. Okay. So we talked a lot about why we want to study statistics, and let me just maybe suggest a few situations, because you might be thinking, so okay, I buy that idea. We are consumer of statistics, so where do I apply that, right? Yeah. So the situations that give rise to statistical analysis will be whenever. Let me choose a different color. So whenever there are many repeated measurements. Essentially, all right. Essentially. So of course, I don't want to keep writing and writing. That will mess up the whole whiteboard, quote and unquote. But essentially, repeated measurements, whether it is done on a selected physical entity like a person, or it is done across many entities like many people. For example, let's say the Singapore population, okay, or 6.2 million. What are some so-called measurements that we can make across each individual? Well, for a start, we can talk about height, weight, right? So the height of every person at this point in 2025, let's say, at this point in each person's life, what's the height of each individual across all the individuals in Singapore? So that's the idea of repeated measurement. We keep measuring height across different subjects, entities, right? Or for that matter, we can select one entity and we can also have repeated measurements. Usually that will result in what we call time series. That means time after time after time, we measure the same thing for the same variable on the same subject. So for example, there is this new COVID-19 drug, let's say, that will quickly, rapidly help to relieve the fever or pain. Okay, good. Is this effective? So we will identify a volunteering patient who will start taking the pill, and then we start to repeatedly measure the temperature, right? Currently the patient has high fever. So after taking the pill, we start to measure the temperature perhaps every 15 minutes, right? So for the same person, we'll do that across 24 hours for 2 days, let's say. Okay, so that would generate a lot of data. I mean, not as in gigabytes of data, but a lot of repeated measurements of the temperature of the person at the same spot, maybe forehead or under the armpit, across 48 hours. So in this situation, right, as in the height of all individuals in Singapore, or the income of all individuals in Singapore, such cases generate a lot of data, and that is a hint, right? That is a hint that you have to do statistical analysis, almost for sure, because no one is going to browse through pages and pages of heights or information of each and every Singaporeans and then say, okay, looks good. You're going to look at numbers scrolling past and then say, okay, good, nice, looks good. When your brain actually has absorbed nothing. It's just massive numbers flipping past the screen. And even for the temperature measurement, right? The time series across time, we have temperature measurement on the efficacy of this new COVID-19 drug. Does it work, right? Does it rapidly reduce the fever and pain. When we collected all the temperature measurements, we are not going to like quickly flip through all the numbers, right? 43, 42, 43, 43, 42, 42, 41.5, 40, 40, 39, right? We're not going to look at it. Oh, looks good. Uh, our brains are not designed to look at the numbers, right? And what if the numbers are printed in a way that is hard to read? Very tiny or very big, right? Flashing past very rapidly or very slow, too slowly. We are going to be having big headaches. So instead of helping, it worsens the analysis. So these situations automatically is going to call for statistical analysis. You see? So whenever there is repeated measurements, right, your spider sense, I hope you will start to develop this statistical spider sense, that you will have this tinkling sensation. Oh, I think I better do something, right? Means better do some statistical analysis before you present the data. You don't actually present data, raw data. You present statistics. So many people misuse the term. Let me present the data that we found. Actually, they don't do that because you don't see them showing pages and pages of numbers. See, I'm done with my analysis. They don't do that, right? They will number crunch and say that after our analysis, we find that the drug is actually quite effective because the average time it takes for the person to go from a standard 43 degrees high fever to 38 degrees mild to acceptable level of low fever is within 10 hours, let's say. Right. Much better than the market available paracetamol, which is 48 hours. Something like that. Yeah. So it will be those consolidated figures. That's statistical output. That has to be. Right? There's no way out. There's no way to present raw data. So you only present statistics. And that's where you use statistical analysis. So the spider sense that I have, and now I share with you, right? Whenever I see repeated measurements, I will think, okay, so we better have analysis done. Okay. Next is the idea, the concept of population, sample, and sampling. Okay. Population and sample, they are basically a kind of parent and child relationship because we learned, right? I think we learned in high school, secondary school, sample is a subset of population. But in reality, when you apply them in real life, the idea of population is not so well defined. I give you an example. What is the average income of Singaporeans in 2024? That's a very legitimate, reasonable, common business question, right? Because you want to decide maybe the pricing of your products based on the income level. It may not be Singapore. It may be Ho Chi Minh City. It may be Kuala Lumpur. It may be so somewhere new to the person, to this regional manager. If regional manager is from Singapore, then put you in Jakarta, Indonesia, you might not be familiar, right? Then you'll be asking, well, for this city, what's the average, right, income level of Indonesians in Jakarta in 2024, right? So that's the kind of situation we have. Now, income will be the population because here the population, we're not talking about country population. We're talking about a bank of numbers. So the statistical term population is not referring to country people in a particular country, not like the population of Singapore, United States, United Kingdom, and so on and so forth. Not like that. But we will have a population, right? So when we say we have a population for analysis, that's to say we have a bag of numbers. Now this bag is where the problem is. Where's the boundary? Okay, is it a large bag or small bag? So population can be large, right? Or it can be small. Large typically depends. It's relative, large and small. Uh, for the income question that I was asking, right? So the average income of Singaporeans in 2020. Now that population of income numbers also associates with the population of Singapore, right? That's the common misunderstanding. But the two populations here, they have different meanings, right? So the population of income, population of income. I didn't use it incorrectly. Population of income. That means the bank of all the income figures of 2024, right? Each number belonging to one Singaporean. Okay. Question is, where's the boundary? Who are considered Singaporeans? Right? Who? Well, you say, okay, those with NRIC. What about permanent residents? Okay, those holding Singapore passport. What about permanent residents? They don't hold Singapore passport. Okay, fine. Those who hold a FIN card, right? Permanent residents, Singaporeans. What about foreigners? They also work in Singapore. They also pay taxes, right? So, do you consider them to be? And you start to have a lot of refined questions, to challenge the boundary. Do you include this or that? And of course, the bulk could be made out of Singaporeans and permanent residents. And the foreigners, even though they might be, defined in a very ambiguous sense, yeah. Of course, IRAS, the income tax authority, will make it very clear. But for our own experiment, we are going to randomly survey, right? So then we will have to define whether foreigners are considered or not. If you have a volunteering, willing foreigner who is willing to share with you his income, right, in 2024, would you take that as a valid entity in the population? Because if it is not, then it is not a proper subset, right? It is not a proper sample. So population is sort of a set of numbers is what we say, but then in real life, how you define that set, who belongs to this set and who doesn't, needs to be very, very clearly defined. And usually it's not easy. For example, maybe there's a Singaporean who earned or worked and earned income from January to November and then get posted out overseas for about to overseas branches, right? And in December, from December onwards. So from January to November, right? The person was in Singapore, but then December onwards, no more. So do you consider that person Singaporean? do you consider that income, which is only 11 out of 12, right? Not a full year income. Do you consider that legitimate? Because it is reflective of the behavior of working professionals in Singapore, right? That people work maybe partial year and then gets shifted out, and something like that. So if you discard, then you are selecting only people who work full year in Singapore. Then you do your analysis. Those who are earning partial year income, you discard. Is that your goal, right? So it becomes it begs more question, right? To make sure that various circumstances are covered, and that's what makes this population rather challenging, right? That's one. Now I talked about population size being large and small, right? Whether it's large and small, the sample will be a part of it. Will be mathematically we call a subset of the population, and being a subset of the population means that whatever is in the sample has to be in the population. But if you do have a sample that is outside the population, then it will be invalid. you're going to be including the income of, let's say, New Yorkers before tax, and it's going to tend to pull up, right? Pull the average higher, right? So a New Yorker who works in Singapore, but then drawing salary from US. The person works in Singapore, yes, physically here in Singapore, but then drawing salary from parent company in US. So it's all US money, taxed in US. So that person's salary converted to Sing dollars is going to, lift up the average, right? So if you pull that person in, right, who didn't derive income from Singapore, that's what the tax authority would say, then you have a problem. And so you want to define your population size boundary very clearly. That's one. Then sample, when you pick the samples, of course, the whole book can be written to talk about the techniques of sampling to ensure non-biasness. You just ask your friends. So if you're a high income earner, you ask your friends, they're all high income earners. And your conclusion is, wow, Singaporeans have very high average income for 2024. That's not correct. If you're starting your career, you have a relatively lower income range, you ask around your friends and they're all starting their careers, right? So whether they started their career with higher relative income or lower relative income, it's all in the lower range area. And so when you average, again, it's going to be non-reflective. So you want actually not a convenient subset surrounding you yourself, right? So our sample usually is pockets of information. Just looking for my. Okay, so pockets of samples from all over as randomly as possible. So those are all samples. All samples. Although when we draw it this way, it looks very distracting and not very easy for study, right? Because it's way easier just to think of sample as a subset like that. But the reality is that it's more like a messed up egg. It's not one sunny side up egg. It's being totally split up into various tiny little pockets as randomly as possible. Also, then you will ensure that you, within your limited capability, you are able to, by chance, right, obtain the income of lower range income earners and higher range income earners and medium range income earners. And of course, if most people are in the medium income range bracket, then most of your samples will also be in the medium range income bracket. Now, why do we sample? That's a good question. Why sample? We sample because population is large. Population size is large. That's one. To begin with, right? Large, again, I mentioned just now, large or small is really relative. Let's just stick with the idea of a lot of people first, right? So that's easy to think about. Now, when you have 6.1 million Singaporeans, and if you, one person, or even a team of 5 people, let's say, right, a group, class group, project group, were to do this population average of income, it's nearly impossible, right? Come on, right? You have to physically reach out to 6.1 million people. Even if you email them, keeping track of 6.1 million people's email, whether they have responded, send them reminders, it's already not easy, much less to talk about physically, meeting those people and asking them what's their income and seeking their consent and so on and so forth, right? So not enough time, not enough effort, right? So no time, no money to begin with to do all these, right? No time, not enough manpower, right? Not enough budget, which is money, not enough people, not enough equipment, because if you need sensors or measurements or instruments to measure, then you need equipment. Not enough technology, and because you don't have powerful servers, so even if you collected 6.1 million, somebody has entered those numbers for you, and which will take a long, long time. Suppose all those are done, you also don't have enough server size to compute, which will take 24 hours to calculate, and you don't have that ability, let's say, and so on and so forth, right? So we just don't have this to process 6.1 million, example, numbers. Remember, population we're talking about here is about number. All right. The number, of course, I use it very liberally. It is data, it is collected information. It's not about people, but rather the measurement of the people. So it can be height, weight, numerical. It can also be favorite sports, right? Singapore is promoting sports, aging sportily. So everyone should have a favorite sports, right? Young and old citizens and fellows, and it can be qualitative terms. So sports, badminton, table tennis, swimming, running, whatnot. So measurements, right? Measurements. So the population of measurements, and we don't have a lot of these resources in general, right? So insufficient resources that require us to trim, right? Our sample, to trim our ability to touch reality. So this gives rise to the idea of sampling, right? Every measurement is a touch, right? I put quote and unquote, of reality. What is reality? Reality means the actual number that we are trying to ascertain. For example, the average income of all Singaporeans in 2024, right? So wait, that's only for 2024. 2023, 2022, we're not interested, right? So it's well defined. So a touch of reality means what's the average? Let's say the average is $79,342.20. I'll just give some numbers. But nobody knows unless that person correctly obtain the truthful, some people hide their income, the truthful income of every single person who worked in Singapore in 2024. And then also handling those fringe cases like foreigners who were posted here drawing salary and this and that, right? Handling all those fringe cases in a very clear cut manner, no ambiguity, right? No, sometimes I add in, sometimes I don't, right? So once you have done that, then you just simply add up all numbers and divide it by 6.1 million, then you're done. That's the literal way of following the formula. But we don't have the time, energy, effort, manpower, resources, budget, physical equipment, technology to touch the reality 6.1 million times. Now you know the reality, right? So reality is such that we have to be humble. We have to scale down our number of touches of reality, and that is what we call the sample size. So by using a small enough sample size n, right, we trade accuracy or precision and accuracy at the same time for ability to get rough estimate. Rough, okay? Probabilistically rough estimate. Okay, I'll explain that a little bit. So, for example, 6.1 million we don't have, and it is just me alone, one person, right? So what? How many how many times of reality can I touch? Within half an hour. Okay, let's say 1 hour. Within an hour, I can reach out to my uncles, my aunties, my friends, my colleagues, and maybe 20 people. Okay, good. Right. So my sample size is 20. And the sample size is 20. Is 20 representative of 6.1 million? Clearly not, right? Clearly not. However, I'm touching reality because for example, if you work in India, you might be getting millions and millions of rupees. If you work in Vietnam, you may be getting billions of dong, Vietnamese dong, right? Billions of that Vietnamese dongs, hundreds of billions of Vietnamese dongs, right? And that that is not going to be very. Those numbers will not be very reflective of Singapore's numbers in Singapore exchange rate. So we want to make sure we get a rough estimate. A rough estimate means it is not in the hundreds of billions. It is not in the tens of $20. By randomly sampling, actually I'm not random enough because I'm asking conveniently, right? But then within limited time, that's the most I can do right now because I can't be calling strangers. I make 100 calls. I might take 2 hours, and only one or two people might, 1%, 2% might just be willing to share their income with a stranger right now. Yeah. So especially with these scam calls coming in these days, who dares? Who will do that, right? So maybe I get zero volunteering information. So I'm just asking conveniently 20 incomes. These are touching realities because they're telling me their actual income, all right, and they are not in the the sky high range, hundreds of millions of dollars or dongs, right? They're also not in the lowly range, like $10, $20. They are anchoring me at the right average level. For example, some might be 50,000, some might be 80,000. So when I average up, it is 63,000 per year. It is wrong, not accurate. Okay, because let's say the actual example, actual population mean income mu is 79, what did I say? 324.50. Okay. Sample income. Sample of 20 people gives X bar, right? This is the common notation used. Gives an average of 6 because people, they don't give down to the last dollar. So I just ask them and they just give me rounded figures, right? So I get something like $67,000. Okay, clearly it is wrong. So accuracy, no good, right? Not so good. Precision means the number of decimal places or digits or significant figures that are truthful. So I can put down some noise, 67113.45. But they are noise. They might jolly well be 000, right? They are not meaningful. So they are not carrying information. So precision is that sense of quality. That means how many significant figures can I rely on, right? So if the truthful number is so high in the precision, we can go down to the last cent because it's accurately 50 cents, not 49 cents, right? Then we can see that it's actually also not good, right? Because instead of a seven significant figure accurate number, we are down to two significant figure non-accurate number. We are trading it off. So accuracy, not so good, but even though it's not exact, it is not far off. So in statistics, we never ask for equality. It is almost impossible. So for determining population mean, and for that matter, a lot of population parameters is what we call population variance, population standard deviation, population maximum, population minimum. All these, if you don't touch reality for all the entities in the population, you will never know. Right? Because if you say the maximum is 80,000, if you never ask until the last person in the population is being surveyed, you never know the last person can be 100,000. So how dare you say that the maximum is 80,000 right now? Yeah. So that's why our accuracy is never going to be 100%. But also, at the same time, we in statistics, we look at it the other way around. It's not bad. It's pretty good, right? Our accuracy is anchoring us at the 67,000 region, which is not exactly 79,000, but it is not telling us the mean is skyrocket high, like 279,000. It is not telling us our mean is unbelievably low, like only $3,000. Right? Like Singapore is an undeveloped country, $3,000 yearly income. So this $67,000 as a average income for 2024, not accurate, but not that bad. That's the way that's the attitude, right? That's the appreciation that we should take up when we do statistics. So if you're the kind who in high school, in your studies, have been insistent on the correct answer down to the last decimal place, you have to switch your mind a little bit. You can still do statistics, and you will learn to like it because we humans are basically a statistical creature. All our cells are statistical in nature. It's never exactness in nature. We are not like Optimus Prime, right? All the parts fit snugly and accurately together down to the last bolt, right? Without any gap. It's precision configuration. No, we are not like that. We are organic. And organic simply means that hundreds and thousands, millions and billions of cells will try to statistically attempt to do their job. For example, if it's red blood cells, we need a lot of red blood cells to carry energy because some red blood cells carry halfway, they disintegrate, losing energy. So how can we rely on a single red blood cell, right? We have to rely on massive amounts. Some will carry halfway and then die off. That's fine, no problem, because hundreds and billions more will continue to do the job. So we totally don't feel anything, right? Our nerves, also same thing. We have redundancy, we have everything, right? If this nerve didn't fire, didn't trigger, another nerve will help to carry the information so that we don't rely on a single or even double or triple. We have lots and lots, statistical amount of cells to convey information, to deliver energy, to move our arms, our muscles and all that stuff. Basically, we are statistical in nature. Our eyes are statistical in nature. That's something I want to talk about maybe in the next lesson, right? So if you see the same picture, let's say just look at the sky, right? Some people look at the sky, the cloud configuration, and then they see a person. Another kid might look at it and say, that's an ice cream. That's a snowman. No, it's ice cream. No, it's a car. But then it's the same cloud. The next moment you look up, this now looks more like a fish. Who knows, right? It's all in our mind, and our eyes just gather the information and then interpret it. Now, if we are robotic, we cannot be having different perception of the same reality, right or not? Yeah. So these are just, you know, manifest behavior. That means they show up, and you and I cannot deny that those human factual behavior, right? That different people look at the same cloud configuration will say different things. Different people look at the same picture. Some will say, "Ee, so ugly." Some people will say, "Look, this is so nice," right? Some people say this is so boring. Some people say this is wonderful. Um, it's statistical. Our entire body and makeup and DNA is statistical in nature. So that's why we are basically always having less accuracy and less precision ourselves. So it should be second nature to us rather than the other way around to be so right infinitely precise and accurate. So hopefully that makes you more you, right? More back to you yourself. If you have been endeavoring to become a super accurate robot calculator all in your life, that's now you should revert back to your human self, right? And because that is to be celebrated. Now, sampling is our way to touch reality. In other words, we don't we don't know another philosophical mindset that we should have. We don't know reality. This is very, very important uh, fact, maybe, and mindset to have. Now, you might say, what? Look, I can see. Seeing is believing? Really? If you have a crowded picture of Tokyo, for example, right, or anywhere, a big city, right, a lot of people. If I say this is, there are 624 people in the picture, do you agree? You know, how would you agree, right? Unless you count. You can't agree, right? You cannot agree until you have counted. We don't know the reality. But then if I say there are a lot of people in the picture, would you agree? You immediately say yes. So, but then reality is there are 825 people. Let's say that's the actual count. If I say 624, you might just say, well, possible, right? You're reluctant. If I say something even largish, like I think there are 925 people. It's closer to the actual number, 800 something. You will kind of more readily agree. But if I say something excessive, there are 5 million people in the picture. Straight away, you don't agree. Right now. So if it's very far away, very wrong in the high sense, in the very wrong, that there is nobody in the picture. Very high in the very wrong in the high sense, very wrong in the low sense. You straight away will disagree, right? But if I say something closer to the exact number of people, your eyes tend to like doing a quick estimate, right? Doing a quick sampling. If this first quadrant has 300 people, second quadrant has 200 people, then roughly up and down, okay, about 1,000 people. You are saying what? 950? Yeah, I tend to agree. Something like that, right? So you're doing a quick sampling, right? Because you divide it into 4 quadrants, you do a quick count, rough estimates, then assuming, right? You make some trade-off, right? You make some trade-off for accuracy and precision. You want it to be fast. You want your answer quick, but you reduce the accuracy and precision. So we are often having a trade-off. So a trade-off. Okay, we don't know the reality until we count it, until you spend the time and 1, 2, 3, 4, 5, 6. But by the time you finish counting, the game is over, right? I mean, it's just a friendly conversation, meant to be half joking, half educational, and then you spend 3 hours counting and recounting just to be sure, right? So that spoils the joke. And so basically, the claim, my claim, and the entity, the mentality I like you to have whenever you're doing statistics is we don't know reality. You have to have this humility. Must have humility. And mindset. Okay? You have to have this sense that I don't know. Okay? I don't know. If you know everything, it will inhibit your desire to go out and measure and gather data and touch reality. So every time you measure, you gather data, you are touching reality. And only when you touch reality, then you know. Okay. Furthermore, if you touch reality last year, you may not have the same reality as this year, right? Just look at the income question. What's the average Singaporean income in 2024? That's why we qualify in 2024, because for 2023, 2022, and then back into the COVID-19 days, it will be different number. The reality was different. So the reality now, in some sense. Okay, so I'm just abbreviating and say we don't know reality. You have to have this. Quick example. Okay, a company's marketing budget and the product sales volume, that means the number of product being sold in the stores, right? Let's say we're selling some cosmetics products. Okay, we claim, right, uh, the higher the marketing budget, the more products will be sold. I'm working there for 20 years. I'm the senior VP. Don't tell me otherwise. I know reality. Fact is, well, when the person says the fact is, without being backed up by data, that so-called the fact is, people like to say that because they want to scare you to think that they know the facts, right? The fact is, the more marketing budget we have, the more we will sell our products. So please give us the 5 million marketing budget that I've been asking for. Now, if we adopt this attitude, we don't know reality, then we start to question. Are you sure? Is it true that the more we advertise, the more we sell our products? True or not? Maybe in the initial phase, yes. The more we advertise, the more we sell our products. Because people didn't know that there is this new facial cream available. So you advertise and people want to try, right? So that's why people buy it. In the second phase, right, the more you advertise, maybe the product was meant for European, American skin. Okay, so or facial, not so much for Asian skin. So it wasn't very effective. So the initial wave of people who bought didn't find it useful. So a lot of blogs and comments and YouTubes and all that, they start to reflect, right? So those will become resistance to your marketing efforts. The more you market, the more the bloggers come out and say, yeah, it's priced very well, branded very well, and marketed very well. But then after I've tried it and all that, it doesn't seem to work, right? So that will be a counter force to make that claim less valid. So maybe the with immense marketing, you still can push up the sales by a bit, but essentially it's flat. Or after some overexposure, the more you market, the worse it is. People now tend to actively avoid and switch over to competitors' brand. Okay, so now you say It's a matter of fact. I know I've been doing this for 20 years, right? So that kind of mentality stops the VP from having a market survey. Is it still true or not? Right. So that's why when you are wearing this statistics consumer hat, you want to be a little bit more humble. Humble, not in the personality sense. That hopefully is true as well. But I'm not more talking about humble in the appreciation of our smallness. Okay, appreciation of our lack of knowing everything is how you start doing statistics, especially for those of you who are also having some partial role in producing statistics, like doing summary, doing PowerPoint presentations, right? You always present statistics. Then you are a producer of statistics. So then you will need to have this. We don't know reality. The moment you say, I know this, then you're in trouble because what you know may be already stale, not applicable, or perhaps what you knew was totally wrong, not the reality. And that would be problematic. Right? So keep this in mind. We don't know reality. The only way we know reality is to perform sampling. Sampling is only way to know reality. That is in statistics. The reality here means anything about the population. Population mean, population standard deviation. It can be, for example, the stock market price. Right? Stock market price, you have seen all the data, but those are past data. Any data you have seen has to be past. Even present immediately becomes past. Because the numbers come in very rapidly, right? So if you're doing speed trading, then every second there's a new price. Actually, every 100 milliseconds there's a new price. Right? So numbers come in very rapidly, and 1 second later, the price 1 second earlier was already outdated, stale. And so you have to keep, looking at the latest. And sampling is our only way to know reality. What's the reality? If you are talking about the average performance, average price performance, it should include the future. It should include, because if your investment horizon is if you invest in this stock, you plan to sell it. You buy in now, but you plan to sell it in J. Then your investment horizon is 24 hours times 3600 seconds per hour. Right, so that's the number of seconds you have. After that, so the average of future stock prices in the yet to come seconds should be averaged out together. You understand what I'm saying? Yeah, that's theoretically. But of course, you might say, how do I do that? Because the numbers haven't been seen. Exactly. That's this part of the population, right? The future is this part of the population that you couldn't sample. It's as if your randomness didn't touch the future, right? I mean, it doesn't make any difference mathematically. Whether you randomly pick, but somehow your randomness always end up in the past, right? Because that's the only thing you can do. But realistically, you cannot sample the future. But that doesn't change anything to the summation formula, to the average formula. It just doesn't, right? So, yet we need to have the sense of also including the prices, the stock prices of the future. Because if future is going to be low, and low, then the average should be very low. Then we might say, oh, this is probably not a good stock to invest in, right? So we want to know the future. That's why even when we're doing statistics, it's and we're talking about sampling and doing population average, it's also inevitable that we end up applying statistics and sampling and various tools in statistics to talk about forecasting and prediction, where the non-sampled area or entities or stock prices for that matter, those measurements that were not sampled due to randomness in normal cases will end up becoming necessarily the future that we are unable to sample, right? So they will be blanked out because we can never somehow accidentally go and measure the future, right? So that's not possible. And yet, statistical theory still applies because statistical theory doesn't differentiate non-sampled measurements numbers from measurements that can never be sampled. That means you randomly didn't pick and you can never pick. They mean nothing. They make no difference to the statistics analysis. That's kind of the beauty of it, right? That allow us to be able to also apply statistical tools and analysis to talk about the future. So, all right. So sampling is the only way to know reality. And a sort of related idea to that is the more we touch, the higher, the more accurate that about the reality we will get, and precision we will get. That's the only way to get higher accuracy and precision. That's the only way, statistically speaking. All right. So all these things that I'm introducing to you now, they kind of are a bit familiar, but a little bit like overdoing, right? Like a bit. Are you sure? It's a bit not so natural. That's more because you haven't been exercising statistical thinking in the statistical sense. All right. So the only way to know reality is to perform sampling. Sampling is to touch. Touch means to measure. Okay. If you want to know the reality accurately, then you want to touch a lot of times. For example, back to the same question. What's the average income of Singaporeans in 2024? So all incomes of Singaporeans in 2024, that's my population. All the numbers, 6.1 million numbers. To know the reality means what's the average of these numbers. That's the reality. I will have to touch reality 6.1 million times, correct? Obviously, we don't have time, budget, and all these things. So we sample. And once we sample, we are trading off accuracy and precision down and down, but not down to zero, just dropping. The smaller the sample size, the more we drop our accuracy and precision. And conversely, the higher, right? I like to talk about larger sample size. N high means high sample size. Accuracy and precision, high. And conversely, N low means both will go down. N high means we touch the reality many times. We measure the individuals, many individuals, right? High income, low income, medium income. And if there were a lot of medium income, then we also end up getting a lot of median incomes, which will weigh our average towards the median, right? Because that's the center of gravity there. And so we'll get a more correct reflection of reality. I don't know if you have heard of this tale about the four blind men and the elephant, right? So just very quickly, there were these four kids. From young, they were blind. So when they grew up, right, somehow there was this man who brought in an elephant. They have never seen an elephant before in their life. So the four men went around, right, very excited, and they end up touching different parts of the elephants. They spread out, right? The one who touched the tail said, ah, now I know. The elephant looks like a brush. Yeah, because the tail has a lot of dried hair, right? So it's like a brush. I can sweep the floor with the elephant. Another who touched the hind leg is very big and almost like a wall, felt that the elephant looks like a pillar. Right? So he says, I can hug the elephant. It's like a pillar. Very nice. Another person who touched the elephant's stomach, which is very flat because it's a huge elephant, say, no, you guys are wrong because the elephant is like a wall. It's so nice to lie on. Finally, the last man touched the elephant's ear. And you know what happened, right? So he says, you guys are all wrong. Elephant feels like a huge leaf. Are they right? Well, each man has a sample size of 1. Now you understand, right? So that we're applying the concept of statistics terms now. So they sample only 1 time. And each has a sense of reality that is not wrong, because elephants do have parts that look like a brush, a pillar, a wall, and a leaf. But it is not the individual shape like these 4 shapes. Neither is it somehow a integration of these 4 shapes, right? We all know that. So the story is to say that if you touch reality 1 time, of course it wasn't a statistical fairy tale, it was just a fairy tale. But I felt that this was an excellent application of statistical analysis. If your sample size is 1 and you touch reality 1 time, your conclusion is having very low accuracy and very low precision. In other words, you conclude that the whole of elephant looks like a leaf, like a brush, like a pillar, like a wall. The whole. That's very low precision. Is it wrong? It's not wrong. It's not wrong, but also very incorrect. Low precision, low accuracy. So what can the man do? I think your brain already is screaming the answer, right? What can the man do to get the right picture, the picture that we have as an elephant? Of course, you say, increase the sample size, right? Their sample size is touch. So they need to touch the elephant more times, maybe with both hands, right? So they can get a bigger picture. Actually, the big picture, right? So they can get a more complete picture. And finally, when they say, oh, elephant, actually it's like a huge animal with 4 legs, with a tail that feels like a brush, having a long trunk, and so on and so forth, right? Then, number 1, their description of elephant will be more accurate, more like what our shape of elephant is. Number 2, they are able to tell more details. They can say that the elephant is not just a wall, but rather elephant has a stomach that feels like a wall, has 4 legs that are huge like pillars. So the details are there. The precision has gone up. Not just the accuracy has gone up, but the precision has also gone up. Right? Yeah. So, but then of course, having more sample size means they take more time. And the owner of the elephant might not have the patience. Hey, you guys, please get off the elephant. I need to go now, right? So limited by the availability of the elephant's time, their sample size again may not be very, very high. So whatever it is, it serves to illustrate, right? That we need to have the idea that the sample size needs to be large. Whenever you are working hard, this is to say working hard, right? So N goes up means working hard. N goes down means save cost. Right. So if you are working very hard, your sample size goes up, then you are working very hard. You have to be working very hard. In case you don't get the idea, if I say, okay, now you, right, student in front. Here's an exercise for you. Right. After this video, please go and interview 2 households. Ask for their income, take the average, and post in the comment. Now, n equals to 2, right? As opposed to, okay, you, the reader of this video, after this video, as an exercise, go and randomly select 20 households. Ask for their income, take the average, and then post in the comment. Now, you can imagine the labor, the chore, the effort, the tiredness associated with reaching out to 20 households, right? Knock, talking and all that stuff before you can finish this exercise. As opposed to just knock 2 times, 2 households. So end high literally means work hard. Now, of course, in the case of using machines, maybe it's not human that work hard, but then machines will have to work hard. In automated production factories, for example, wafer manufacturing, cars and components and all that, either robotic arms, right, or mechanical robots will randomly select the physical product, whether it's the wafer chip or the component, right, or cars themselves, will randomly select and then put through the analysis, laser inspection, video scanning and whatnot, right, perform the quality checks, and then do the necessary reports and analysis. So if there are defects found, then perhaps they may have to discard the whole batch or something like that, right? So all these are automated, so nobody is involved. But then if you want to have high quality production, that means almost zero defect sent to the customer, then what do? You better inspect more, right? Have high sample size. You want to know the reality that all your products have 0 defects. Or if there's any, it is being picked out. Okay, no product, 0 product leaves our factory. So if that is the reality, but is it the reality? If this is the reality you want, is it the reality you are having? Then you say, oh, I know, we put in a lot of investment. Our factory has all the latest equipment, by sheer environmental factors rather than measurement. You deduce or conclude indirectly, you infer that there's high quality. And that's dangerous because you are not having this humility here. Just because you invest in high-end equipment and machines doesn't mean the produced goods will have 0 defects. I don't know. Okay, so then we increase sample size, right? I want to know the real reality with high accuracy and high precision, because we cannot afford to send a malfunctioning product to our customer, like a car that doesn't work or somehow breaks down on the highway. And that would be dangerous, right? So that would be not just dangerous for that passenger, but also very damaging to our brand, right? And so on and so forth, right? So as you can see. So again, statistics and in quality control is a very tight relationship. QCs, right, use Six Sigma. Six Sigma basically is the sigma that we are talking about, the standard deviation that is found in statistics. So it's very tight connection between them. And of course, which factory doesn't do quality checks these days, right? So statistics are used a lot in the manufacturing, logistics, supply chain industries. Okay, one more point that I want to talk about before we conclude this session is the sense that there are 2 types of statistics. Now, I know some of you will say it's qualitative and quantitative and all. Yeah, those will be the subcategorization. But rather, descriptive and inferential. And you want to know that. Not just because I want to give you a test and you will get 100 marks. That may be necessary too, right, in your university stats course. But it is important for you as a consumer of statistics to know when are you dealing with descriptive statistics. Because if that is the case, right, for descriptive statistics, if you are dealing with descriptive statistics, then the idea is you don't really want to challenge the results. Okay, let me explain what that means. You don't want to challenge any presented descriptive statistics, as opposed to inferential statistics. Inferential statistics. Okay, inferential statistics, of course, is the opposite. You should always doubt. Such a claim or conclusions. Okay, you should always doubt. And should always doubt means even if you are convinced and you accept the conclusions, you accept it reluctantly, you accept it still with a, what we say, pinch of salt. That means you are very ready to give it up the moment there is additional data contradicting the conclusion and so on and so forth. Right? In other words, it's not a fact. Descriptive statistics, these are facts. They are not susceptible to being invalidated. In other words, if I say the average of 100 numbers is 50, 100 random numbers, if I say it's 50, right? And of course, we're not saying that the person presenting the statistics is trying to create fake news or something, or is cheating. We're talking about honestly presenting it. If I say that the average of 100 random numbers is 50, there's no need for you to doubt me. Because if you doubt me, if you challenge me, I say, okay, here are the numbers, here are the 100 random numbers, go ahead. And you will find that your average is the same as what I present. Okay, fine, maybe you got 50.01. I said 50. But that's not something that we are going to argue about, right? In other words, it is not meaningful to start an argument based on facts. Descriptive statistics themselves are facts because they are summaries of facts. Okay, they're summaries of facts. Facts are the raw data, and summaries of facts. What are summaries of facts? Example, average. The mode, the median, the maximum, the minimum, the standard deviation, right, and so on and so forth. All these measures that summarize a lot of numbers, or we call it functions, that summarize a lot of numbers into one number. Basically, these averages, means, modes, and medians, and max and mins, they are also facts themselves. And including charts. All kinds of charts. Because if you say my chart is fabricated, not believable. I just give you the data, right? And you produce the same chart, you will see the same chart. The same type of chart, that is. For example, if I created a pie chart, you say that's not true. I give you the data, you plot a pie chart, you will get the same pie chart. I mean, there's no way, right? Unless I'm not, I kind of modified the data, but we're not talking about those situations. We're talking about, factual. So charts inclusive, all kinds of charts, all kinds of charts are considered facts because given the same data set, Excel spreadsheet, database, whatnot, you will get the same chart, right? And given the specification. Bar chart, okay, give me 5 bars from this range to this range. You will get the same. Whether you're doing it in R, Python, Excel, whatever, you will get back the same chart, right? So there's no point to argue about chart. To say that this chart is wrongly drawn or whatnot. No, there's no point. So don't waste your time and effort arguing about descriptive stats. That's the takeaway for you. Spend your time, however, scrutinizing, examining the inferential stats, right? So here, inferential stats, okay, they are not, obviously they're not going to be facts. They are going to be assessments. Assessments are subjective. Partially. And of course, subjective doesn't mean it's no good. Subjective is the reason why we go to expert surgeon, expert doctors, right, senior doctors who give their subjective expert assessment of our body conditions. And that's why we feel more assured, right? Whether it is, if they say it's fine, then we feel more assured that it's fine. If they say something is wrong, we have reason to worry. We have reason to take additional measures and so on and so forth. That's why, right? So subjective, I'm not trying to say it's a bad thing, but I'm trying to say it is a subjective thing. It is the reason why you have ground to doubt. And this is where, or rather inferential statistics, is where you want to spend more time on. If you want to argue, right, if you want to disagree, if you want to debate, you want to look at inferential claims, right? So what form does this take? It takes the form of conclusions, all right, claims, suggestions, adjectives. All adjectives essentially, right, like big and beautiful, big, beautiful, these are adjectives and they are inferential in nature, right? They are subjective, right? Why is it beautiful? Very personal, right? It may be beautiful to you, but not beautiful to me. So when you see these, when you see conclusions, therefore, we should do this. Why? So you should think. Doesn't mean you want to be nasty to the presenter, right? I'm just saying, when you think, why must we do that? Okay, there are essentially 2 outcomes. It makes you doubt and disagree with the presenter, or once you found the answer or the backing to agree with the presenter, you all the more agree with the presenter with confidence and assurance, right? So, give you an example. We talk about so much about the form of these descriptive and inferential statistics. What form do they take in reality, right? So, summaries of facts, they are descriptive in nature. Conclusions, claims, suggestions, and all the adjectives are inferential in nature. So here is example. Class A and Class B students, right? They take the test, same test. Now a report is made. The average of Class A is 65. Is that descriptive or inferential? Okay, good. That's descriptive because I'm just stating a matter of fact. Unless you want me to show you individually, right? Student one is gets 63 marks, student two gets 92 marks. If I give you all these, you go and take the average, you will get the average of 65, maybe 64.95. Okay, fine, 65, right? So I'm just presenting you as a matter of fact, and it is descriptive. Don't challenge that. Okay, but then now I present, dear principal, the average of class A's recent quiz is 65, which is pretty good. Okay, so now what? Okay, there's a descriptive part. The average is 65, right? And then I had a conclusion or an adjective. Pretty good. And you want to be having this spider sense, right? Red alerts, right? Why? It doesn't mean you jump off and immediately disagree with me. Doesn't mean the principal must say, hey, you know what? I studied statistics and applications and I want to challenge you. Why do you say it's pretty good? Yeah, maybe the principal would just say, why is it pretty good? Man? And it's a ground for being challenged. It's a legitimate challenge. Why? Why did you say it's pretty good? Right? So the pretty good part, it's a declaration. It's an adjective trying to sell to the principal, right? That 65 average, actually it's quite good lah, yeah. So please don't record any penalty on my mark or something, right? Maybe so there's some ulterior motive, or maybe factually it's actually pretty good, right? So one should doubt this. One should question. Let's say I'm the teacher who presented this. Class A, the average is 65, which is pretty good. Now, of course, for me, I also learned statistics and applications, right? So I'm going to anticipate that my audience, the principal here, is going to have this doubt in his mind. So before the principal even asks, I already substantiate my ground. See, that's the difference, right? If I learned statistics and applications, I know that people will have doubt. It's probably a friendly doubt. It means they're just not very sure, but they're not going to challenge me and tear up my presentation. But when the doubt is lurking in their mind, I fail to convince them. I fail to get a buy-in. And they will tell their friends or their colleagues, I'm not very sure, he said that this is pretty good, but... So, in anticipation of that, I'm going to say, Class A, the average for the quiz is 65, which is pretty good because I also teach Class B, right? For the same quiz, Class B got only average of 49. See? That's why I have reason to say 65 is pretty good. Okay, now that you have seen my last card, right? I've show hand my my last card. You can agree with me. Oh yeah, 65 of course is way better than 49 as an average. So class A perhaps is doing better. That's interesting. Okay, fine. Then we can have our discussion. But I, as the presenter, right, if I know that inferential statistics is where people will have doubt and suspicion on, I will want to sort of work it off before they even raise the question. To the layman person who might not have been made aware of these differences and distinctions, they might just also subconsciously felt rather uneasy. He kept saying very good, very good. I don't know why it's good, sometimes you could have that. But the sort of very good salesman will just keep saying very good, very good. And if you repeat many times enough, remember we are statistical. Huh? If you repeat many times enough, audience will tend to believe. Right. So if you, of course, it's half a joke that if you repeat a sort of a lie frequently enough to many people all the time, somehow it becomes accepted as reality, that kind of meaning. But that's more because we are not robots. We are statistical in nature. One time we don't believe, two times we don't believe, three, four times more, we start to wonder whether we should believe or not, right? If we hear a few more times from our friends, colleagues, strangers, we just might want to believe that it's true. Yeah, something like that. And I'm sure I'm not making this up. You have your own personal experience, right? So if I'm the presenter, being aware of this potential, let's say, problematic area of my presentation, right? So if I leave that unanswered, I just say pretty good, then I seem like a hollow salesman. Right? I'm just trying to say what I think. I didn't say I think it's pretty good, but rather I just say average is 65, which is pretty good. Sounds like certain politician, right? Average is 65, which is pretty good, right? Yeah. So you don't give further references for the audience to believe in your choice of conclusion and adjective. Then it remains as such. You know, that is, the audience walk away with a little bit of doubt, and that is usually not so good. And so you want to preempt some of these things. And those people, of course, if you are the audience, you want to start thinking about or observing or isolating these manifest situations. Whenever there's claim that's made, suggestion that's being made, right? I suggest we should do this because we should give remedial lessons to class B, right? Or we should remove the remedial lessons for class A because it's pretty good, right? So these are suggested actions, right? Why? Why do you say it's pretty good, right? So these are inferred conclusions. They are inferential statistics. Ultimately, right, if you look at it and say, actually, isn't it true that when you say class B, their average is 49, you just present 65 and 49, people will agree. And it's no longer inferential. 65 indeed is greater than 49. Both are descriptives, right? So where's the inferential? The problem is, right, what you're saying is absolutely true. If we are given all the background facts and assumptions and context and everything. The point, however, is most of the time, presenter is not trying to bluff people, but they might have omitted what they think are details that will take up time unnecessarily. They might have gloss over. That means they just present the conclusion to management board, right? So unless they ask for further details, I don't present. Okay, they might have only the time and attention span for making the conclusions. So in most management presentation, the trust is there that you have done your work. You're not trying to fake certain suggestions or make certain claims unnecessarily and so on. The trust is there, right? So can you get to the point? What should we do? Right. So that's the kind of situation. But then, of course, if you are the management, you sit there, you should have a thinking mind. What should you think? Are you making inferential claims? Why did you say it's very good? Of course, with the trust that you will explain, right? I think it is very good because 65 is quite good, right? If you hear that, then of course you will fall off your chair, isn't it? How can you say that, right? Then you will be able to. Then you are, number one, asking the right question. Number two, you actually have filtered off the fake presenter who just think I feel, right? From the good presenter, the real presenter who reviews that, class B average is 49, so hey, 65 is actually good. Right? So now you can see, right, this simple example, but they occur in many different flavors and versions and takes and contexts that you, with your own domain expertise, will want to marry this, set of my tools, statistical philosophies and thinking and mindsets with your business context and domain. Okay. Now that you're wearing a statistical thinking hat, then you know where to spend your energy and time and to become a wiser audience and decision maker in general. Okay. So with that, I thank you very much for your attention and I'll see you in the next video. Bye.